In today's lesson, we will be looking at the chemical activity series of metals. Two goals that we're going to get out of this lesson is, number one, explain the significance of activity series. What does it really tell us? What does it do? And then number two, be able to predict whether or not a given reaction will occur and its products. So the significance of an activity series. The activity series tells us how reactive metals are. So whether or not they will actually perform, go through a chemical reaction. The predicting part is we'll realize that, well, yes, hypothetically or theoretically, we could figure out what could happen. In reality, only some reactions will happen. So that's what the activity series chart will give us, is be able to identify which reactions will occur based upon their chemical activity. So we'll be able to look at how easy or how difficult will it be for a reaction to occur, and again, ultimately be able to predict the outcome of an actual chemical reaction. Okay, there are two parts to the activity series chart. And the actual activity series chart in our book is on page 286. The two parts, number one, if you look at the activity series chart, you're going to see the different sections of metals. And within each section, there's a description. And that description talks about whether or not those metals will react with three things: water, acids, and oxygen. Now, there could be other elements. There could be other chemicals. For example, will an element react with nitrogen gas? Will an element react with carbon dioxide? Or other things. For our purposes, we don't care about those other what-ifs. We're only looking at those three: water, acids, and oxygen, because they're very common and they're frequently used. The second thing this chart is going to tell us is whether or not metals will be able to trade places. So the actual predicting of, will a replacement reaction occur? Now, you've got descriptions for the first part. In this part, in the second one, the actual positioning of the metals on that chart, the vertical positioning, is going to help us with that. It's like a ranking system. There's no numbers to it, but it does give us a ranking system. For our purposes, this activity series is not going to apply to double replacement reactions or combustion reactions. We'll take care of double replacement reactions later. And as far as combustion reactions are concerned, if there's oxygen present and there's heat present, they're always going to happen. So there's nothing really to refer back to predict the outcome of a reaction. All right, one last thing about the structure of this activity series. If you look on the one in the book or the one here on the screen, the elements are listed in a vertical pattern. And you notice lithium and rubidium are the first two, silver, platinum, and gold are the last three. A couple things to think about here. The elements at the top of this chart are the most reactive metals. Lithium, rubidium, sodium, calcium, all those, potassium. They're very reactive. They'll react with just about anything. The ones at the bottom are very unreactive. What that means is they're very difficult for them to actually go through a chemical reaction. The second part of this description is also very important because this talks about the replacement reactions. The elements at the top want to be in a compound. That's when they're the most stable. They are not stable as isolated elements. They're stable when they're in a compound. So they want to be in a compound, and then if they're already in a compound, they're going to stay that way. The elements at the bottom, kind of the opposite. They're more stable when they're alone. So if they're not alone, they want to be alone. And once they are alone, they're going to stay alone. Just a simple hypothetical is if you went to your backyard, grabbed a shovel, and started digging up your yard, hypothetically, you could dig up lithium. Now, when you dig up lithium, you're not going to find pure lithium. You're going to find lithium bonded to something else in a chemical. You won't find it alone or isolated in its pure form. Now, keep digging your backyard and you get lucky and you dig up some gold. When you dig up the gold, you will find it in its pure form, not bonded to other things. So that's kind of what we talk about. Compounds or wanting to be by themselves. All right, so it's really important that you kind of keep those phrases together. All right, so we're going to start off with these 4 reactions. You're actually going to look at the descriptions in that activity series and be able to predict just simply yes or no, does it occur? Okay. A couple things here as you work through. Pay attention here. You've got H2OL and H2OG. H2OG is steam. Okay, significant difference between steam and liquid H2O. Also HCl. Again, you don't see that formula on the chart, but you need to recognize that's hydrochloric acid. So what I'm going to do here is I'll just pause for a second, give you an opportunity to work on these, and again, if it comes back too quick, just pause it again, let yourself finish them up. Okay, coming back to these reactions, if you look on the activity series chart, you're going to find copper in the 4th section. And again, there's no description in terms of acids. So according to the activity series, there is no reaction that occurs between copper and hydrochloric acid. Aluminum and steam, we find aluminum. It's in the 2nd section. It does say it'll react with steam. So that would be a yes. Zinc plus liquid H2O. Zinc is in that 2nd section. It does not say cold water. So our answer would be no. And then iron plus oxygen. Iron's in that 2nd section. Does say it will react with oxygen. So we have a yes. Okay. So again, that's all you need to be able to do is read that activity series and be able to predict the outcome. Now, if you noticed, the questions were asked there's 2 ways they can be asked. The first way is, the first question is just simply yes or no. Does the reaction occur? Then what usually will happen is if it's a yes, then predict the products. And so they could have you go back through the 2 that said yes. You actually figure out the products and go from there. Another way questions could be worded is, first of all, they could just say figure out the products and then come back with just a final yes or no, do they occur? So you will see questions written both ways. And again, it's just your, I guess it's a little more convenient if they ask it the first set of questions, yes or no, and if it's a yes, you do the products. If it's a no, then you're done. Another way they could get asked is they could just straight up give you the entire reaction and just simply yes or no, does it occur? Well, H2SO4 is sulfuric acid, so you got nickel and an acid. Nickel is in that 3rd group. It does react with acids, so it's a yes. We got manganese and liquid H2O. Manganese is in that 2nd section. It only reacts with steam, so we've got a no. And then we've got cobalt and oxygen, which reacts is in the 3rd section. It's a yes because it does react with oxygen. So again, you look at the reaction, you find the metals involved, you read the description, and you determine then what the outcome is. Okay, the next thing that we will do is we are going to look at the positioning of the elements involved, and based upon their positioning, be able to predict whether or not elements will trade places. So a couple quick examples here. We notice here we've got copper and sodium reaction, and then we've got a calcium and sodium reaction. If we look here, we've got copper by itself, sodium in a compound, and then sodium by itself and copper in a compound. If we were back in section 2, we'd say, okay, yeah, metals trade places, predict products, balance, and so on and so forth. In reality, only one of these reactions will actually occur. So again, we go back and look on the activity series, and we realize that sodium is higher on the chart than copper. Sodium being higher means compound, copper by itself, or lower on the chart means alone. So that's how they are most stable. Sodium as a compound, copper alone. If we look here in the first example, that's how they are beginning as reactants. Copper alone, sodium in a compound. Therefore, nothing's going to happen. In the second reaction, we have sodium alone, copper in a compound. That is not how they're most stable. Therefore, yes, they will trade places to become more stable. Copper is alone now, and sodium is in a compound. We look at calcium and sodium. Look on the activity series. Calcium is higher than sodium. Now, even though they are both very high on the chart, it is an absolute ranking. So calcium is still higher. Therefore, compound, sodium is lower, even though it's right next to it. Therefore, it's alone. Calcium wants to be in a compound. Sodium wants to be alone. In the first example, that's not how they're most stable. Therefore, there will be a reaction. Then we have sodium by itself and calcium in a compound, which is their most stable form. Therefore, the second one will not occur. So again, in the positioning of those metals, will they trade or not trade? Depends on which one's higher and which one's lower, which one's already alone and which one's in a compound. And be able to just look at that order. The last thing on the chart is it does list the halogens. Now in your book, it lists them as the same, kind of like one big chart, but I want you to think of it as two separate charts. So it's their own chart, but the rules are applied the same way. And what we mean by that is fluorine is the most reactive. Therefore, it wants to be in a compound. Iodine is less reactive. Therefore, it wants to be alone. And if we look at these two examples, fluorine and chlorine, they're right next to each other, but fluorine is higher. Fluorine alone, chlorine in a compound. It's not how they're the most stable. So yes, they will react. Chlorine is by itself. Fluorine is in a compound. That already is their most stable form. Therefore, they don't want to trade. They're not going to change. And we have a no reaction. So again, as you go through these different reactions, you just have to be able to interpret that chart, be able to predict the outcome based upon their positioning in the ranking or their descriptions within each section.